Welcome to the New Books Network.
Hello, everybody, and welcome back to New Books in Gender, a podcast channel on New Books Network. I'm Dr. Christina Gessler, the host of the channel. Today, we'll be talking to Professor Gina Rippon about her new book, Gender and the Brain, How Neuroscience Explodes the Myths of the Male and Female Minds. Welcome to the show, Gina.
Thank you very much for inviting me.
I'm so glad you're here. I am really excited to talk about this book. It's got so many great myths that I know you're going to debunk for us today and explain the science behind why the myths are wrong. Before we get into that, I was wondering if you would please tell us about yourself.
Okay, my official title is Professor Emeritus of Cognitive Neuroimaging, which effectively means I'm a cognitive neuroscience. I work in a research centre at Aston University in Birmingham, in the Aston Brain Centre. And we're lucky enough there to have all of the cutting-edge, state-of-the-art imaging techniques. So when I'm doing active research, which I actually haven't done for some time now because I've been writing a book, I'm using the sort of classic brain imaging techniques that people are probably aware of, the EEG and MRI, fMRI, but also an unusual system looking at the magnetic fields associated with brain activity, which is called a magnetoencephalogram. So those are the techniques I use. I investigate, the basis of my work is investigation in developmental disorders like autism. So work with children and young people. But most recently, I've been writing a book, but I also have a role in the public communication of science, and that's increasingly taking over my time. And so I do a lot of external talks like this, for example, and I go and visit schools, particularly secondary schools. Another part of my activities is concern about the underrepresentation of women in science. So that's very often part of the talks I give to schools and in public communication venues, etc. I write about sex differences in the brain. It's sex differences and how biology has researched into these has been really the thread which has run through all my career. But I'm also interested in the political context of these kind of questions. So I also look at the history of research into sex differences and try and follow the threads through to what we're doing today. Personally, I have a twin brother. So as somebody pointed out, I'm a kind of living experiment about sex differences, obviously born at the same time, to see whether or not any of those kind of claims about the differences between males and females play out at a personal level. And I also have two daughters and a grandson, so I have a bit of experience of children of both kinds, in inverted commas. And I think that's me.
Well, thank you for sharing that about yourself. I wonder if for the listeners, you could just give us the sort of elevator pitch summary of your book.
I guess what it's about, and each of these would have to be qualified in classic academic fashion, is the question of sex differences in the brain. Are there any? And that's an important question, which I explore. If there are, where do they come from? And that really is the whole history of this sort of investigation. And also, what do they mean for the brain's owners? So if indeed there are differences between men's brains and women's brains, how much does that explain what we see in terms of differences in men and women in their personality and their behaviour? So that's the elevator pitch.
Well, that would get me to pick up the book.
Excellent.
It's a good pitch. So you mentioned a bit that someone specifically asked you to write this book. Is that what inspired you to write it?
Yes and no. It was a thought festering away for a long time. But I gave a talk at the Royal Institution in London in 2016. And it was about the miscommunication of science. It was talking about how amazing breakthroughs in science can be misunderstood and misrepresented. So I'm just trying to remember the title of the talk. It was something about, it was about how neuro-nonsense joined psychobabble to keep women in their place. So it was effectively saying, because I used sex differences or the research into sex differences as a very, very good example of how a particular research agenda, A, was in itself potentially flawed, and B, how that research agenda then, the findings from that research agenda, then translated into misunderstood and misrepresented public communication. And there was, in fact, interesting, there was both an agent and a publisher at the talk, and both of them separately approached me afterwards and said, you really should write a book about this. And I went with the agent as I knew nothing at all about writing popular science books. And as it turned out, the other person who was the publisher, it actually was then published by that publishing house. So those two people actually were the midwives, if you like, of this particular book. But I had by then been giving quite a lot of talks about the issues. So the headlines at least were established in my head.
The book really takes us through sort of the history of where these gender ideas are rooted in culture, and then takes us through various scientific explanations of why they're there, and then pretty thoroughly debunks both the science and the beliefs that the science was supposedly proving. Is that a fairly
yes,
apt characterization of at least the first few chapters?
yeah, that's exactly right. And I mean, I think some of the publicity blurb on the cover says, do you have a male brain or a female brain, or are we asking the wrong question? And that captured nicely, in a way, what the book is about. It's saying there has been this centuries-old belief that men's and women's brains are different, and that is the basis of gender gaps today of whatever kind. And that's been a given. And people will proudly say, decades of neuroscience research have shown. But I was interested in how brains got to be different. I thought I'm going to go back and look more carefully at A, where this idea came from, and B, what kind of research has been carried out in order to support this assertion. And it was at that point I realized that, the history of this research into this particular question is, not to put too fine a point on it, deeply flawed for all sorts of reasons, particularly, the assumptions behind it, the political context that's entangled with the research, the assumption from the beginning that there is a difference between men's and women's brains, and the early measures that were used. If they didn't come up with that as the answer, then the measures were discarded. So the assumption was that this was a definite fact, and if you didn't prove that with your science, then there was something wrong with your science, and so you had to find another way of proving it. And I think that makes a very good case study for some of the problems we see in science. Science always portrays itself as a very pure, objective, methodologically driven discipline, which generally it is. But sometimes people from outside need to say, you should be aware that the questions you ask may in fact have some kind of political context. The filters you use to decide what data to collect, how to analyze those data, themselves may have some kind of political context. You personally may have some kind of value judgment behind the interpretation of your data and how you write it up. And all of that feeds into the beliefs that individuals absorb and sustain the stereotypes associated with them, if we're looking at things like male and female brains.
And In the early chapters, you take us through some of these early ways of trying to study the brain. And you point out that if they wanted to study the actual brain, they could only work with a dead brain.
That's right.
They didn't have the imaging techniques that we have today, so they were already at a disadvantage because the brain was already compromised. It was no longer alive and functioning and well. And the person that it had been removed from had met with either a terrible accident or a terrible illness. So the brain was no longer at its peak, shall we say. And that they came to all of these studies with the bias, as you said, of how is a male brain different from a female brain, which then informed their whole hypothesis and their whole quest, really. Could you talk about some of these early forms of study, including phrenology and some of these skull measuring techniques and things for the listeners?
Yes, yeah. I mean, I think it's certainly when you look back, we talk about the end of the 18th, beginning of the 19th century, and it was becoming clear that understanding the brain was going to be the secret to understanding human beings, human behavior, human ability. But what the scientists at the time did was, because they didn't have access to brains, as you said, other than dead or diseased or damaged brains, what they did was a sort of reverse engineering. So they looked at society as it was then constituted and said clearly women are inferior because they were politically, socially, financially, educationally inferior, because that's the way society was structured. So they worked backwards from the status quo and said this must arise from differences in the brain. And therefore, we are going to find the source of those differences. We are going to find the source of that inferiority. And so very early on, very basic techniques, for example, taking an empty skull and filling it with birdseed and weighing the birdseed to see how big, or to guess how big the brain might have been that had occupied that skull. The basic assumption being characteristically that the bigger the better. So the early assumptions were that men's brains must be bigger than women's brains. And it was found that on average, and I think that's an important caveat, which we'll come back to, men's brains were indeed 5 ounces heavier than women's brains. And so there's big excitement. And, now we've found the answer. Men have got bigger brains, and that's why they're, leaders of armies and businesses and are heads of political parties, etc. And women do not have any significant place in society, apart from the odd exception, which, as one of the scientists, Gustave Le Bon, said was so unusual that it was a bit like the birth of a two-headed gorilla and could be ignored. So when you look at some of the views that these male scientists had of women, very definitely as inferior beings, and I'm afraid that includes Charles Darwin, you do wonder about the objectivity of the science, because they clearly believed that they were inferior specimens. So they did, as I say, they measured brain size, and then that turned out not to be a very useful technique, because, as somebody said, if you're just looking at the size of brains, then in fact, that makes no sense, because sperm whales and elephants have got bigger brains, and therefore, we need to have a new measure for understanding brains. And then they started looking at maybe the ratio of the size of the brain to the size of the body, all sorts of mathematical jiggery-pokery to come up with the answer they wanted, which was that there was some kind of scale at the top of which there were white, because that was part of the argument as well, upper class educated males, and further down were women and children, and further down lower classes and other races. So that was exactly what science was doing. And then they said, well, maybe we need a more detailed description of the brain. So they started feeling bumps on the head, assuming that the bumps on a skull might reflect the size of particular parts of the brain underneath. So we had the science of phrenology, And then somebody said, oh, well, you could tell a lot about what a brain was like by taking very obscure and detailed measurements of the skull. So looking at, the ratio of the length of the earlobe to the depth of the forehead kind of thing. So very, very tortuous ways of trying to come up with measures of an organ that they had no access to, really. And of course, that went on really almost until the 1990s, when brain imaging emerged. Obviously, in the interim, there had been access to brains via research that was done during brain surgery, for example, or very detailed analysis of the behavioral consequences of damage to brains. So, for example, after the First World War, there was a lot of study of the kind of deficits in behavior that were suffered by individuals who'd had different sorts of brain injury. So again, reverse engineering, that something has happened and let's track it backwards and say somebody can no longer speak and this is the part of their brain that was damaged. So that must be the part of the brain that does language. So we had these wonderful maps which had little blobs on it saying, this bit does language, this bit does emotion, etc. So that was the early history, as you say, a long period of time when very profound and detailed theories about the relationship between being a man and being a woman and what kind of brain you might have were established without actually being able to look at brains.
And you talk about how these early ideas persist even now in both popular culture and really in biases that even scientists have. You describe it as whack-a-mole myths. Can you talk about your phrase whack-a-mole myths, which I love? I'm going to try to use that in as many sentences as possible going forward. Well, I'm a women and gender historian, and I think whack-a-mole myths very aptly describes a lot of what I spend time in the classroom doing, just mining what myths the students have brought, and by the end of the semester thinking we've really dealt with them, and find out on the final exam, nope, a bunch of them are popping back up. These are whack-a-mole myths. They're so pervasive, and they inform not just the general society, but they are brought into all disciplines and often are unexamined. We're just not aware that we carry the biases that we do. And one of the things you talk about quite a lot in the book is how stereotypes become embedded and in the brain, and how they are pervasive in how we our brain works as a predictor in understanding information and guessing what's going to happen. It uses stereotypes as part of that predicting mechanism. Yep. So all of that sort of explains why whack-a-mole myths are so frustrating for scholars. Can you talk about that a bit?
Yeah, that's a brilliant summary of the book. Fantastic. I think the idea, the whack-a-mole myths is really the idea that I guess I first sort of got involved in challenging the assumptions of research into sex differences way back in the sort of 1990s, when in the UK anyway, it's sort of called a biological politics movement, where the observation was made that women's biology had somehow become weaponized as a rationale for keeping women in their place, for reasons why there weren't women in certain occupations, why there weren't women Nobel Prize winners, etc., etc. And so people were saying that the focus has always been on women's biology as initially inferior, later on vulnerable, because in the 19th century, early 20th century, there was certainly the idea that women's brains shouldn't be exposed to the damages of higher education because they were too fragile to cope with the consequences. So the idea was that biology at that point, women scientists were challenging this and saying, that if we look at how society is structured, if we look at how boys and girls are educated differently, the whole kind of second wave of feminism, this explains differences between men and women. So we must ignore biology, which is not. I got involved in that. I would not say now that we can ignore biology, because we know much more about how biology is embedded in those kind of processes anyway. But certainly what you did was looked very carefully at the research conclusions that were being touted, were being relied upon to actually say, scientists have shown this. This might be an inconvenient truth, but men and women are different, and men are better at mathematics and visuospatial tasks, and women are better at language tasks, etc. So challenging the research and saying, well, actually, if you look at not just one study, but the hundreds of studies that have been done, have they all stood the test of time? Have they all found the same thing? If you look in the small print, if you like, were they taking thousands and making thousands and thousands of different comparisons and actually coming up with only 3 that were significant, and that's what they focused on and ignored the similarities. So you keep challenging those, and you think, right, that's sorted. And I was part of that in the 1980s. And then once I moved to Aston and got much more involved in the sort of technical aspect of neuroscience, for various reasons, I was asked to revisit and say, how has neuroimaging contributed to this debate? And I was horrified by the way in which these amazing techniques that I was using, that I was very proud of, were being misrepresented in what I called a wave of neurotrash. And very much the same research problems, but using different techniques, were emerging, and people were proudly touting the results. And hence the whack-a-mole myth. You think, right, I've sorted that. People won't think that anymore. And then, a couple of years down the line, you find almost exactly the same question being asked with the same conclusion being come to. So that's the whack-a-mole aspect of the book. The other aspect of your very great summary was the idea that we now understand that brains are they're actually much more outgoing, proactive, predictive. I talk about the 3 Ps of the brain. Our brains are predictive, plastic, and permeable. So the idea is that our brains aren't just sort of passive recipients of information. They are actually cruising the world, if you like, and their owners' experience for rules, for understanding, generating shortcuts, even stereotypes, so that their owner doesn't have to process all the information. There's, quick and easy, good enough type solutions. If you hear this kind of sound, this is what it's likely to mean. If you see that sight, it's what it's likely to mean. But even more complicated social rules as well, social scripts and social understanding. So our brain is proactively looking around the world for rules. And with respect to gender, some of the most profound descriptive and proscriptive rules are found in gender stereotypes. So the brain will cheerfully be absorbing those and saying to its owner, you're a girl, you're a boy, this is what girls do, this is what boys do. If you don't do this, then actually you won't be part of the necessary in-group, you'll be rejected, your self-esteem will suffer, etc. And we also know that in adults, the brain still remains plastic and flexible and can change as a part of experiences. We used to think that was very characteristic of the developing brain, the baby acquiring skills as it grew, and the brain was hugely plastic. But there was an assumption there was some kind of developmental endpoint. The brain was fixed and hardwired at a certain point very early on, relatively, in our lives. And after that, that was the brain you had till you got old or ill and it started falling off it. So understanding that, it really meant that if, for example, you had different experiences, we know that people who acquire very complex skills, that can be shown in their brain. But if, for example, you hadn't been exposed to those skills because you were male or female, if you didn't play with construction toys of the kind or didn't have particular hobbies or sports, then having those experiences would change your brain, and not having the experiences obviously wouldn't change your brain, but would make your brain different. And finally, the third P, permeable, is that the brain doesn't operate in a kind of social vacuum. So you can give somebody exactly the same task, but you can frame it in a context which says, this is a task that you're not likely to be very good at, but do your best, or this is a task that people like you are very good at. So let's see how you do. Same task, but the brain will respond differently to the different contexts of the task. So all of those things make us realize that the brain is much more profoundly affected by what's going on in the outside world, particularly including stereotypes which will affect attitudes and experiences. And it's possibly that which is behind some of the differences that emerge, the differences in behavior and the differences in brains.
That really leapt out at me when I was reading. And it all seems to be of a piece, just from a layperson's point of view, that self-esteem is so much more important in brain response than I realized until I was reading this, that the body actually feels emotional slights and rejections in the same way that it feels physical pain. It's very painful to have injuries to your self-esteem. And you talked about how there is a sense of self, but it's continually in dialogue almost with the external world, that the self is looking for cues from the social peers around them. Am I doing this right? How are you receiving this? What do you think of it? And so the self is always sort of calibrating in response to these external stimuli. And that, of course, then a lot of that external stimuli is how well you are performing your gender.
Mm-hmm.
And one of the profound, for me, examples you gave in the book was you had just given birth to your second daughter, and she was about 10 minutes old, and she let out a cry, and she was one of 9 babies born, and the other 8 were male, and she was the loudest crier, according to the nurse. And the nurse said to you, well, that's not very ladylike at all. And so your daughter was 10 minutes old and had received profound stimuli already about her natural cry was too loud for her gender. And that struck me as how quickly we are being taught how the world is receiving our self, how we present ourselves, and how they're saying, yes or no, you got that right, you got that wrong.
I think, yes. I mean, and the context also was that the boys were applauded for their noise, cracking pair of lungs, I think. So, that was the context, that the same cry was rewarded differently. But yes, and I think that's absolutely right. I mean, I love your characterization of what I was trying to convey about how the self is in constant dialogue. And the emergence of a particular kind of identity and understanding of the rules of your, what I call the social script, or the rules of social engagement, is a powerful and ongoing process in the brain. I mean, a lot of the time that people are, in quotes, looking at resting state, very often it's the areas to do with self-reflection, self-reference, which remain active. So it's almost as though, apart from anything else the world is throwing at it, the brain is still constantly updating self-identity, self-reference. Are you getting this right? Are you going to look a fool if you do this? Are your peers going to, think you're brave, wonderful? Are your peers going to think you're an absolute idiot and reject you? And a lot of the work that I've been involved in is makes me think I'm an unpleasant sort of person, is looking at ways of measuring a loss of self-esteem by giving people tasks in the scanner where their self-esteem is dented in some way, or they're asked to reflect on some awful mistake they've made, or they're asked to take part in a kind of online video game where everybody else seems to be having a great time and not involving them. And as you said, it's the same areas of the brain are activated by those kind of social torture, if you like, as real pain. And I think that should make us realise that the brain is wired to make us social, and being a successful social being is a very powerful driver in the brain. And if we start to look at sort of extremes of behavioural pathology, such as depression and eating disorders, self-harm, for example, all of those are pathologies of self-esteem. And of course, eating disorders is the mental health problem which has the highest mortality rate of any. So a loss of self-esteem or poor self-image can be, as hugely self-destructive. So not just, assuming that the basic survival instincts are, making sure you've got enough food and drink and sex, etc. It's also that you're a successful social being. And if you're not, then that is a powerfully negative driver in human behavior.
It seems to be something that's beginning to make the public consciousness at this time, because of the pandemic and so many people having to quarantine, that we're now in lay people getting the information that loneliness is as detrimental to health as quite heavy smoking is. And you mentioned in the book that one of the ways to learn more about the effect on the brain of how our social world treats us would be to do more studies of adolescents, because their peer group has such a profound influence on them. And also, I would think tied to that is the fact that the gender roles change dramatically for adolescents. What was okay for the baby boys to wail really loudly would not really be appropriate as a teenage boy to, do that in class. He wouldn't get lauded the way the nurses would in the infant ward did for them. And how the boys and girls both have to perform their gender has changed dramatically, but also the stakes have been raised on that for them. Things that perhaps a boy would accept in a girl when she was younger and a girl would accept in another girl when she was younger. They've now changed the rules on each other quite profoundly. And that can lead to isolation and loneliness for those who aren't able to quickly catch up to the new rule set.
Yeah. I think, in fact, interestingly, there was a fairly large chunk of my book which didn't make it into the final version about the adolescent brain, mainly because, as you've already touched on, it's such a rich area of study and evidence for some of the work I was talking about, because adolescent brains have surprisingly only been studied fairly recently, and it used to just be assumed that adolescent brains were smaller brains getting bigger on the way to being adults, and that there was a sort of fairly straight trajectory. Nobody really realized that adolescence is very much a time of the brain completely reorganizing itself. And nice, well-established pathways, links between different areas of the brain actually are pruned back very vigorously. And there's quite marked disconnect between different areas of the brain during adolescence. And one of the reorganizations that's going on is as the adolescent as changing their social identity, because they are starting to have an identity as an independent adult and an individual who is no longer part of a small family network, a small family school group, but an individual who is emerging as an individual who is much more reliant on their peers. And the study of peer pressure on the affective brain is really intriguing. So no longer, respecting teachers and they ever did, teachers and parents as the controller of their lives and the fount of all wisdom, etc. They're now more interested in what their peers think of them, and so the social pressures that we touched on earlier, are very powerful in adolescence. And the loss of self-esteem is much more detrimental in adolescence. And it is, of course, in adolescence that a lot of mental health problems emerge. And it may well be that this is, this sort of rewiring, reorganization of the brain has gone awry. And that's why there are the problems there are.
You mentioned in the book, if I have this correctly, please let me know, that the two greatest growth times of the brain are a period when they're babies and then when they're adolescents.
Mm-hmm. Yes, well, different sorts of growth. I mean, the growth in baby brains is absolutely astonishing. Whenever I sort of look at the statistics, I just think that is amazing what is going on minute by minute in baby brains. And that's a huge period of growth, which we always knew about because babies are born with smaller brains, but a lot of the growth is to do with the growth and pathways and organisation and connections and the nerves becoming more insulated, etc. So you have pretty much the adult number of neurons when you're born, although that's not such an absolute metric as it used to be. And all of the growth that goes on in your brain is to do with increasing connections between those nerve cells. So that's an amazing period of growth. Adolescence actually is less a period of growth and almost a period of reduction, because the pathways that babies acquire, there are many, many more pathways in baby and young children's brains than there are in adult brains, because it's a bit like a sort of wildly growing shrub, where everything's connected to everything else. And then at some point it becomes unmanageable, and you have to start to train it, and you trim back the pathways that aren't used. And there is a certain amount of cell death. So a lot of changes in the adolescent brain are actually almost to do with reduction in size. But again, a vast amount of reorganization, which is the key differences there.
And so what you were saying is then if the pruning or the reorganization goes awry or the wrong things are pruned, that may account for the rise of mental illness?
I think that is certainly a basis of a lot of the problems. I don't think it's a coincidence that many of the mental illnesses we look at occur in adolescence. I mean, there are developmental disorders, but there are also disorders, but there are others which occur characteristically at the time of adolescence.
One of the things that you note, and you touched on it briefly in the beginning, was that there were early studies and ongoing studies that find that there are a great deal of similarities, but you call those a file folder problem, and you say that studies where you don't find differences between the sexes, it's less likely that the scientists will submit the research for publication, and that if they do, that it will be accepted. Can you talk about the gatekeeper bias of, well, we're looking for differences, we're not looking for similarities, so that's what we publish.
Yeah, the file drawer problem, or sometimes what I call the iceberg problem, where you get a nice body of literature, published literature, which if you don't look at it very closely, you might say, there's thousands of papers which report sex differences, therefore we know there are sex differences. But when you start to look at them, you realize they're talking about different differences. And one paper will find that men have got a bigger amygdala, and another paper will say, no, we've looked at all the amygdala studies and there are no differences, but women have got a thicker cortex or something. So lots and lots of research, not fraudulent, but starting to come up with different findings, which if you look at the variability within groups of males and groups of females, and come back to that, it makes sense. But it's also the case that the way in which science has been constructed, it's starting to change a bit now. If you had a hypothesis that there was a difference and you didn't find one, then maybe you didn't publish the study, you thought, I've got that wrong, and you put it away in the filing cabinet. or you did submit it and somebody says, oh, well, everybody knows there's a sex difference in language ability and you didn't find one, therefore there must be something wrong with your study and it didn't get published. So there's probably, invariably, a vast body of probably quite acceptable science which reports that actually men's and women's brains are more similar than they are different, but it doesn't get to see the light of day because that's not the question that was being asked. And if you think about it, if this was sort of a clinical trial in terms of, for example, people trying to find a vaccine for COVID, if you tried a vaccine out on a million people and it made a difference in 100 of them, but no difference in the rest, you wouldn't accept that vaccine. And in a way, there's an extreme characterization or caricature even, but that's what's going on in this research. And one of the things that I mentioned there, the variability, comes back to a phrase I mentioned earlier called on average. And what people don't realize, and again, the way in which science is reported, is that the differences we're talking about between groups of males and groups of females are absolutely tiny. If you took the data from a group of males and data from a group of females on a behavioral study or a brain structure study, put them on the same axes, you'd get the classic sort of bell-shaped curve for each group. Pretty wide variability, which I think is actually very interesting in itself. And then you see how much those data overlap. And what that means is that we spent decades of research looking at tiny differences. The differences are so tiny that actually they're not very informative. Because if they overlap so much, knowing that somebody's male or female is not going to tell you how they're going to behave on a particular task, or being given a particular brain measure or brain image even, is not going to, you're not going to be able to interpret that and say, oh, well, that must have come from a man or that must have come from a woman. And I think that's something that people don't realize, because the use of the term different in common parlance means pretty distinct, that you'd be able to, see two different examples of two groups walking down the street and you'd be able to tell which belong to which generally, of course, you can with males and females. And of course you can if you're only going to focus on their genitals mainly. But when you're talking about their brains and their behavior, they're not that distinct, but we still use the term different. So I think I've slightly gone off of the point of your original question, but it's really to say that that's something which is quite important to remember when we're talking about science in this area or research findings in this area.
I think it's lovely that you opened that topic of how the public understands terms that mean one thing to a field, who uses it as a part of their quantitative and qualitative process, and means another thing in common language use among the population that's reading it in a magazine as a summary of the science, or who's hearing a report read over BBC or CNN News. We have a similar pitfall in history where we use the word average to explain ages, and we don't mean common. So we don't mean everybody died when they were 42. And if someone was 43, they looked around and said, I'm the oldest person I've ever seen. We mean mathematical average.
Yes, that's right.
But the common understanding is, 40 was really old for that time period, or everybody was married by the time they were 16. And not that you've ever watched TV with me, and you won't want to after I say this, but I tend to shout at the TV, that's not how we meant average. But once it's translated into the common usage, that everybody understands it that way. And one of the things I appreciated about your book was you took us through how scientists use this term, how they're analyzing their data, why they put it into their report, and how once it goes into public usage for the common, the lay people, for the common news audience, we begin interpreting it through what we think those same terms mean. And it leads to further whack-a-mole myths.
Yes, yeah. I mean, I think significant is a good example of that, because significant means something different if you're talking about statistical significance. But people are a bit more careful now, but people will talk about significant differences, and one assumed that meant they were important, as opposed to just an outcome of a statistical comparison. And the other one, particularly in this area, is essential, where biologists use the term essential to mean to do with some kind of characteristic which is imbued or donated or endowed by your biology. So if you talk about the essential difference, it means there is some kind of biological basis for the difference. But if you took a group of people in the street and said, what do you think the term essential means? I would bet that most of them would say really, really important and something we really, really need. And that's part of the difficulty one has in challenging some of the assumptions and the consequences of the assumptions about the differences, whether or not there are differences between male and female brains, which I think there are. By the way, I'm not a sex difference denier, as I have been accused of being, in the same kind of tone of voice as climate change denier, with the same consequences for human civilization, presumably. So if you talk about terms in that way, then I think that's it's important to remember that.
One of the other things I really appreciated about the book is you talked about how science still has biases. I know as a historian, we were told to, try to be as scientific as possible, which meant, really just look at the facts as pure facts and don't bring in your biases and question everything. And you say, well, science has bias as well, particularly if they're doing a study and they might say to the female participants, men typically do better at this, but have a go at it. Or they do the reverse. They offer pink toys to boys who've already been well imprinted on the idea that pink is a girl toy, and the boys are going through their own brain predictive measures of, am I supposed to touch that? Would it be okay? Do boys use girls' toys? And then they sort of mark, boys really just don't like picking up Barbie dolls. They were very hesitant. They put them down quickly. They didn't engage with them. And one of the things that you point out throughout the book is, well, here are biases that are built into these studies. And here's biases that are built into the subjects of this study. It's hard to find someone young enough that they haven't been taught anything at all about gender. And in the baby chapter, you say they're social sponges. So it does become enormously challenging to, when I'm reading it, to think, how would you find someone who hasn't been taught at all about gender or expectations, or isn't reading the facial cues of the scientist who's presenting the study?
Yep.
Which you talk quite a bit about, how babies, from baby onward, it's one of our most important skills is to be able to predict by reading the body language of the person what it is that they want from us.
That's right. I mean, I think the issue of bias is really important because scientists tend to sort of bristle and become very defensive if you talk about bias, because, the kind of raison d'etre of science is that you're objective and not biased. And it's trying to convince people, and be aware yourself, that you are biased, and that the subject you're studying, the participants you're measuring, bring their own biases with them, and you should try and control for those. And sometimes they're sort of experiential biases. So, again, it sounds a bit like you, shouting at the radio or the television or the, latest Sunday article or whatever. When people say, oh, we can now measure thousands and thousands of brains, and, here's a study looking at 5,000 male brains and 5,000 female brains. And wow, look, we found these differences. And there's this kind of triumphant, edge to those of you who believe men's and women's brains are quite similar. Here, look, I found a difference, kind of thing. And you say, well, okay, so how old are those people? What was their education like? What kind of occupation did they have they had? Are they retired? You might be able to control for age, because you'd acknowledge age is a factor which changes brains. But have you actually looked at the whole other list of variables that might change that individual's brain? And you also need to be aware as a brain imager that if you're dealing with a plastic brain, all you're getting when you're measuring your cohort over however many weeks you're collecting data is a snapshot of each individual's brain as it is at that time. If they came back the following year having, I don't know, done a different course, learned a different language, become sporty, become unsporty, all of those things will have changed their brain. And so, as I say, it is only a snapshot. So those are the kind of things we need to be aware of. So, not become defensive and say I have control for, I'm not biased, but be aware that you are biased and that the questions you ask are in themselves biased. And so you need to be as open-minded as you can and say, what other factors might have produced this kind of result? Or have I not asked the right questions? Or, is the fact that I'm looking for a difference? I mean, the wonderful brain images we have are actually predicated on there being a difference between a resting state and a task activation, or males and females. And what brain imaging does is averages out all of the similarities in order to emphasize the differences, because that's the story they want to tell, which is fine. But people looking at, uninformed people looking at those would not realize that. They would say, oh, look, how the brain lights up in, only one side in males when they're using language and both sides in females. And, gosh, that proves that women are better at language. And then all the downstream consequences of the research, which is, I think, an important aspect that neuroscientists sometimes forget. We're not talking about anatomy. We're not just diligently measuring increasingly tiny characteristics of the brain in order to give a detailed anatomical outline of brains. We're actually making inferences about what those differences mean. This person will be more emotional, less able to do, understand facial expressions or whatever it is your research is feeding into. So an awareness of bias is really important in this work. And a lot of what I'm doing, and people like Cordelia Fine and Rebecca Jordan-Young, who've written in this, Daphne Joel, with the same thing, that, this area of research is so important, we must get it right. Not this area of research is, as we have been accused, feminazi, a bunch of dangerous female neuroscientists. We're not saying you shouldn't do this research because the truths you're coming up with are inconvenient to our political views. We're saying this research is really important, so we must get it right. Sorry, that was a rant.
And you talk about, no, it's lovely. You talk about the downstream consequences in the book as a worry that you have, that these findings can be appropriated or misappropriated to affect policy, access, opportunity, promotions, across the board for both genders, all genders. And this is an ethical concern that you have. Yes?
Yeah, absolutely. I mean, I think education is a very dramatic battleground with respect to how neuroscience informs the eagerness. This is not a kind of political manipulation. It's the eagerness of educators to get things right. So a lot of educational policies are predicated on the fact that boys and girls learn differently, that boys and girls will grow up to be different things. And they will claim, there's a real hunger, a very admirable hunger for neuroscience. So that's where neuroscience has to be responsible and say, what you're doing, people are really listening. One of the things I say in talks is, there's very few certainties in science, but I'm assuming that everybody in the audience reading the book, listening to the podcast, has a brain. And therefore, we all have a very invested interest in what people have to say about our brains, which is why quite possibly people have very, very strong opinions that think you're wrong because their brain isn't like that and that's not how they experience life, etc. But it is a hugely important topic. So responsibility is a very key issue, and the consequences do worry me, particularly when, I give talks in schools and you go and talk to 14-year-old girls who have a very powerful belief that, for example, science, the underrepresentation of science, of women in science is a hobby horse of mine. They think, well, science isn't for women, so we won't do science. And, that's the age in which the curriculum is such that they can almost choose to drop science, but certainly not to focus on science or to ensure that they're adequately scientifically educated. And I think that's a real shame. It's a real loss to themselves and to, a loss of human capital. Another rant, sorry.
And you have a section about, no, you have a whole section about that in the book that I hope that listeners will take the opportunity to read that and look seriously at what are the barriers to females in science, and it's not their brains. That's pretty clearly laid out, and I think it's very important.
Yeah,
Go
interestingly,
ahead.
I mean, today is Ada Lovelace Day, and one of the things we're looking at is the way now we know how profound an effect that culture can have on the brain itself. So we're still looking at a biological process. You should say, well, the underrepresentation of women in science, the focus has always been on there being something wrong with a woman, they've not got the right sort of brain or whatever. But actually, science should look at itself, should look at the absence of role models as a sort of self-fulfilling prophecy, but also the attitude that science has towards women, and whether or not there is an even playing field, which has been claimed. How welcoming are they to women? Is there any evidence of gender bias in publications, in grants, in success in science? The breathless hailing of the fact that 2 women won the Nobel Prize in Chemistry this year. That's great, but also the fact that it was hailed with such breathless surprise is an indication that science has got a long way to go before there really is an even playing field for women. And now that we know that, again, in a kind of self-fulfilling prophecy, if, however bright you are, if the culture in which your brain is trying to operate is constantly denting your self-esteem, not expecting you to be successful, downplaying any successes you do have, then that will be a powerful brain-changing effect.
And I'm glad that you brought up the downplaying, because there was a question that I wanted to be sure to ask you before we ran out of time, which was about inner limiters and self-silencing, and how important it is you think about overriding our inner limiters. In fact, you thanked both your grandmothers for overriding their inner limiters in the opening of the book. So I want to be sure you have a chance to thank your grandmothers and tell us what that means about inner limiters and how you would override that.
I'm really glad you asked that question, because that's one of the chapters I'm most proud of, and one of the chapters I get asked about least. Yes, this is my sort of suggestion that there is a process within the brain as part of the social network, which is inhibitory. Most of the time we look at parts of the brain which activate different processes. This is a go, no-go area, which actually inhibits behavior, which has negative consequences, stops you making mistakes, which is great, but it could also inhibit behavior, which inhibits social behavior, which has negative social consequences. So we're back to self-esteem. So if you're functioning in a culture where your ability is not acknowledged, where you're generally viewed as inferior or incompetent, then there is a powerful inhibitory process in the brain which says, this is not for you. This is not making you happy. I think you should withdraw. And there is a process called self-silencing, where the sort of individual self-identity kind of disintegrates, because it's so much reliant on feedback from the outside world. And if that feedback is negative, then gradually individuals characteristically, behaviorally, will start to withdraw. And that's in typical behavior. And it can also become profound in atypical behavior, very much a characteristic of depression in women, depression being much more common in women. And so my suggestion is that a lot of the lack of engagement, for example, in science, or the lack of self-confidence, which people claim is behind gender gaps in pay, for example, may be a consequence of how the brain has been shaped by the attitude of females, by the attitude towards females of the society in which they're functioning. So in order to succeed unexpectedly, for example, by winning the Nobel Prize, you have to really overcome that inner limiter. So, it's an additional barrier. And I think that would be worthy of study in understanding gender gaps, which in a way is what all of this is about. So this is not just an exercise in anatomy. It's trying to understand how our experience of males and females is different and how males and females achieve differently.
I wish we had more time to talk. For listeners, this book is 424 pages long. There is so much more that is so fascinating about this book that we haven't even gotten to touch on. And you can't see it, but I have notes taped up all around my microphone that I have with questions I haven't even had time to ask. So I know that listeners, when they pick up a copy of the book, yes, we need a part 2, and definitely listeners need to pick up a copy of the book and delve into this really fascinating topic that really has ramifications for so many fields of study. In the few minutes we have left, would you like to tell us what you're working on now?
Yes, I mean, there's 2 areas linked. One of the areas I mentioned, I do a lot of work with autism. And autism has always been characterized as a male problem. Indeed, it's used as a justification for why we must study sex differences, because more males have autism than females, and therefore, in order to understand autism, we must understand sex differences in the brain, which, I wouldn't set aside. But it's becoming increasingly clear that there are very many girls and women on the spectrum who have gone unrecognized and unsupported and unhelped for very long periods of time, because it was always assumed that autism was a male problem. So that is an area which I'm exploring. And particularly the idea, quite possibly, that autism expresses itself differently in girls. I mean, the diagnostic dice, if you like, are loaded against women anyway, because it's assumed that it was a boy problem, and therefore you ask boy-type questions in order to understand how atypical the behaviour is. But it could be it presents differently in girls, and maybe girls manage the camouflaging necessary to escape being identified early on, because they become aware that they're atypical and that somehow they don't fit in, but they're good enough for perhaps small early parts of their lives to fly beneath the radar, again, as it's been described. So that's an area where the 2 areas of my interest, autism and gender, are coming together. And there's also the possibility of a second book, which is linked to this idea of the inner limiter, and that in order to understand mental health problems, huge gender gaps in mental health problems between males and females, and the fact that they are increasing quite dramatically in young females more than in young males, it's worth looking at the brain-changing consequences of external factors, and not just assuming that we're looking at somebody who's got some kind of deficient biology which makes them prone to depression or eating disorders or self-harm, etc. So those are ongoing projects at the moment.
So you'll be able to bring back the adolescent research that was becoming so large you had to cut it out of this book. You'll be able to possibly bring some of that back
Absolutely.
to the new book?
Well spotted. Yes, that's right. Yes. And in fact, there was also quite a lot of material about mental health in women. But as you mentioned, the book is already 400 pages long, and I think the editor thought, enough is enough. And perhaps with an eye on a second book.
Well, I can't wait for the second book, and I definitely want you to come back and tell us about that. Thank you so much for being on the show today, Professor Gina Rippon, and telling us about gender and our brains. I'm Dr. Christina Gessler, and you've been listening to New Books Network. Please join us again.